Hi, you guys. This is the last example that we did in class today, and this is really closest to what your homework problems are like from the textbook. And then next class, we're going to be doing just more practice with all types of related rates problems. So in this example, we have two cars, A and B, are traveling towards the same intersection. So I've kind of drawn a picture of what we can think of the intersection. And neither driver plans to stop. Not very safe. Car A is a half a mile from the intersection, moving east at 40 miles per hour. So I've drawn that. I've shown that car A is traveling in the east direction, and I'm calling the distance from car A to the intersection X, because that's changing as the car is driving. It's decreasing that distance. And then we are given that car A is 0.5 miles from the intersection, moving east at 40 miles per hour. Car B is 0.75 miles from the intersection, moving south at 60 miles per hour. So I've drawn so that we can see that car B is moving south, and I'm calling the distance of car B from the intersection Y, because that distance is also changing as time is passing, and Y is decreasing as the car is moving closer and closer to the intersection. The question that we need to answer is, how fast is the distance between the two cars changing? So that is actually this distance here. Because as X and Y are decreasing, as the cars are getting closer and closer to the intersection, that distance is going to also get smaller and smaller. And I'm going to call that distance S. So looking at our picture here, we can see the relationship, Pythagorean theorem, x squared plus y squared is equal to s squared. Okay, we are given a couple of rates. We're given that dx over dt is equal to negative 40 miles per hour, and I put a negative on this rate because x is decreasing as time is passing. And then dy over dt is equal to negative 60 miles per hour. And we want to find ds over dt when x is equal, at the moment that x is equal to 0.5 miles and y is equal to 0.75 miles. And we don't know what s is, but we can find what s is with our equation. So 0.5 squared plus 0.75 squared equals to s squared. So s is going to be equal to the square root of 0.8125. So s equals the square root of 0.8125 miles. Okay, so we've stated what we're given, we've stated what we're going to find, which rate we're going to find, so we're ready to differentiate with respect to t. So we have 2x times dx over dt plus 2y times dy over dt equals to 2s times ds over dt. Okay, so let's look at what we're substituting in. We have x, we have y, we have s, we have dx over dt, and we have dy over dt. So we're ready to substitute those values in and solve for ds over dt. Okay, so now just some algebra. We get ds over dt equals to, that'll be negative 40 plus, not plus, minus 90 over 2 times the square root of 0.8125. I'm going to pop that into my calculator to get approximation. And we get approximately negative 72, and that'll be miles per hour. So the distance between the two cars is decreasing at a rate of 72 miles per hour when, let's just say when car A is 0.5 miles from the intersection. And I'll also put car B. So, and when car B is 0.75 miles from the intersection. Okay, so remember, draw a picture if you can, state the given information, the given rates, and then state which rate you are solving for, right? Because they're related rates, so you're solving for a rate, and when exactly it is that you're solving for that rate. So which instantaneous rate of change you are calculating.